Hey, welcome to part 2 of my chessboard project. In this video I work on the Hall effect sensor, as well as expanding the LED matrix to fit an actual size of a chessboard. First I started working on a prototype using a breadboard. This is a series of 8 Hall effect sensors with a 74HC165 chip that converted all 8 of these to one serial output. With a working prototype, I wanted to make a PCB so that I can condense this into a smaller space. I also bought a glass chess set and stuffed some magnets in them. And then I took all of the 8 sensors on one PCB and tested them with these chess pieces to make sure that they were actually able to work. The test I'm showing now is a bit backwards, so just imagine that the PCB is flipped out upside down and then the LEDs will correlate to the right position. But hey, look, you can do 2 at the same time, which is neat. With one PCB working, I started soldering the other 8 PCB boards. As you can see through the iterations, I got better at the wire layout, and it got cleaner and better with each iteration. I also needed 64 Hall effect sensors to be able to plug into these PCB boards. As you may have noticed, some of the Hall effect sensors have different lengths of the wires. This is so that they can all reach the same point of different squares on the chessboard. And this from left to right is the process I took of creating each PCB board. So while I was soldering, I had some 3D printers running and prototyping these squares. Once I found the right size, I printed 4 of these 4x4 matrices and glued them together to get an 8x8 chessboard. Now was the time to scale up. I took that 3D printed grid and traced it onto a box and found the center of each square. Then I drilled holes in all the squares and started putting some similar LEDs in through those holes. These are kind of like Christmas lights, since I didn't want to solder all of the different strips together. I wrote some simple code that would have a Hall effect sensor turn on associated light when it detected a piece above it. And this is when I first started to see what the chessboard had the potential to be. Although I did run into a couple of strange bugs, I was just inspired by the project by how cool the chess pieces looked with the LEDs underneath them. I started working with processing on a version of Pong and pushed that to the Arduino over Bluetooth, and now I have my first prototype of Pong working. I lost some of the lights by this point, so I couldn't use the full extent of the board, but I tested it with my family and got some user feedback on it. So one of the things was it was hard to identify who had won, so I changed the color of the paddles after somebody wins. The ball also stays in the center for a little bit, just to give you some time to process what happened. And this is what the board looks like in a dark space while you're playing Snake. I just think the effect it has on the ceiling is super cool. Sadly, it was time to shed our box shell and start working on downsizing to get a slimmer chessboard. I 3D printed some stands and used those to stand the chessboard on it, and then I started putting the rest of those Hall effect sensors into the chessboard. The sensors didn't quite fit past the LEDs, so I had to pull them all out for this step, but I finally got them all in. I used the older matrix to test each of the sensors to make sure the entire matrix still works. And here's what it looks like with all the chess pieces on the board. Now I must say, this isn't a fully working IoT chessboard just yet. Right now this is just turning on the lights when it detects the chess piece above it. So at the moment I can play a super cool game of chess, it's just I can't play it over the internet just yet. If you do want to see that, please subscribe to the channel because that video is coming out next week. Do you have any questions, concerns, or spiffy remarks? Please leave them in the comments below. Thanks for watching this video and have a great day.